Hi, I'm Atul Patel, Senior Software Engineer at Sandblaze. Today we're excited to introduce our latest technology of IRiser. IRiser stands for Intelligent Riser, a family of patented precision test tools engineered to amplify the power of Sandblaze, SP Express, RM5, and DT5 systems. The IRiser provides PCIe, lane and sideband signal glitching, 3.3 and 12 volt power monitoring, 3.3 volt and 12 volt power measurement, precise control of power, data path, and sideband signals, which enable users to develop complex test scenarios and real-world failure test cases. The IRiser integrates seamlessly with certified Sandblaze test suites. It enhances standard compliance testing by incorporating multiple device-level stress factors to further ensure PCIe and NVMe device design robustness. It can also be paired with an optional EDSFF to M.2 adapter to enable additional test capabilities for M.2 form factor devices. It provides PLN/PLA measurements, allowing customers to see the ramifications of their actions, and also high-speed signal glitching of PCI signals, accurate control of all out-of-band signals, DMR directly up to 1,000,000 nanoseconds per second, and accurate timing on signal assertion and deassertion. As you can see, our patented IRiser5 Plus product develops plenty of test options. Let's talk about a couple of use cases where the IRiser5 Plus helps with testing. The use of PLN, powerless notification. The host sets the PLN to tell the drive that the power is going away. The drive will respond with a PLA I'm ready. This is a good use case to test customer firmware. Also, asserting reset and measurement time lets you assert reset until your device is ready. For example, you can assert reset for different links and set the amount of time to see firmware behavior based on those values. Let's put this in a system now and get a closer look. Here we have an SP Express RM5 system. We'll put the card in one of the supported slots here and then take a look at the capabilities through the software. In the RM5 system, the cards are compatible in slots 6, 7, 8, and 9. Now let's install an IRiser5 into an SP Express RM5 system. If your equipment is shipped to you with the IRisers already installed, be sure to check that they are seated properly, as things can shift during shipping. That's it for the hardware portion. Matt will now walk you through the IRiser5 capabilities through the Certified by Sandblaze software. Matt, take it away.
Now that Atul has put an IRiser5 Plus in slot 7, we can take a look at what you can do within the software. First, I will show you how to access the new functionality in the Sandblaze web interface. Once you arrive at the home page, you'll need to navigate to the Sandblaze Express Manager page. This is located on the left-hand side tree menu. For those unfamiliar with the Sandblaze system, this is the main page for seeing drive status, running tests, and now accessing the IRiser web functionality. When a Sandblaze system is powered on, it automatically discovers any IRisers present. These are then shown on this page as a button with the IRiser version. Let's click on one of these buttons to bring up the new functionality. The GPIO tab is a live view of the current state of signals on the IRiser. In here, we can click in the table to flip a signal's direction from an input to an output, or flip the value from a 0 to a 1, and vice versa. Clicking the Enable Logging checkbox enables signal logging for the IRiser. This will record all changes that occur for every signal that has logging enabled. This functionality is particularly useful for checking if the drive toggles signals in a particular order or after a certain time. For example, some drives support the power loss protection mechanism that is in place to safeguard data integrity during power loss. This logging functionality would clearly indicate if the drive toggled the PLA power loss acknowledgement signal after the PLN power loss notification signal is toggled to indicate that the drive is in a safe state to lose power. Moving along to the Actions tab. This tab is used to create, edit, and delete sequences of actions. Starting off, an action is an instruction to the IRiser to change one or more signals at a specific interval. A sequence is just a collection of one or more actions. The sequence can then be run at will by the user to perform these actions on the IRiser. Currently on screen, there are no actions or sequences to edit though, so let's add a new one. Over at the right-hand side of the screen is a drop-down menu. Clicking this will take us to layouts to edit, delete, or add new actions. Adding an action is simple. We'll press the Add Action button at the bottom of the page, and then we'll go over what these options are. You can now see a table has appeared on the screen, showing us the action we just created. The header row shows the signal GPIO numbers and names. The first two rows beneath this are our new action. Here we can see what the action's signal directions and values will be when this action is run. There's two ways to edit these. We can either click on an element in the table to flip the value, or enter the equivalent change as a hexadecimal value in the right-hand side. Now let's add a few more actions to this sequence. We're going to make them last 80 milliseconds each, and we're going to give them a description so that we remember what they were for. Let's edit action 2 again. As action 2 is the last action in this sequence, we can change what happens after it executes. Currently, the sequence stops. I want to make it so that action 2 loops back to action 0 upon completion. I've decided I no longer want action 1. Let's delete action 1. We now know the basics of how to edit, delete, and add new actions. At the top of the page, there's a drop-down menu to view other sequences on this IRiser. Let's select sequence 5 that I created earlier. This sequence contains 3 actions. Action 5 lasts for 1 second, Action 6 lasts for 100 microseconds, and Action 7 lasts for 2 seconds. Let's make a quick change to Action 6 to toggle burst off for that 100 microsecond interval. As you may have noticed, a new chart has appeared at the bottom to represent the changes in the sequence in a more visual way. The y-axis tells us the signals that change. The x-axis tells us the time they will change at. We can mouse over and zoom in to inspect this more thoroughly to ensure timings are correct. Action 6 toggles burst off for 100 microseconds, and Action 7 toggles it on again. This looks correct. Let's export it so it can be saved and loaded onto other IRisers in the future. Moving on from the Actions tab, we'll take a look at the Signals tab next. This tab is designed to run the sequences we just created. First, we'll select a sequence from the dropdown. This will populate the screen with data about that specific sequence. Next, we'll hit Start to start the sequence running. You will see a vertical line scroll through the page from left to right. This is an almost exact representation of what the sequence is currently doing in real time. As this page updates automatically, it will also update to show sequences that are started or stopped from the command line. For sequences that loop at the end instead of stop, this sequence will continue to loop forever until manually stopped. If a sequence is stopped by the user, as you can see on screen, you can choose whether you want to resume or restart the sequence from the beginning. Lastly, we'll take a look at the IRiser Power tab. This is the newest set of functionality added for the IRiser in the web interface. Here we can record and view previous power recordings. I'll first describe what options are available on screen, then we'll create our first recording. Let's start at the top of the page. Here we can see a main tab. This is what is currently being shown on screen. Here we are able to start, stop, view, and delete recordings. When we choose to view a recording, more tabs will be populated here. Moving slightly down the screen, we can see a blue horizontal bar with some options. First, the frequency. This is the number of samples that will be recorded per second. This ranges from 1 Hz to whatever the max for the IRiser is that you're using. Slightly right of the frequency is the recording options. This dictates when the recording will stop. If the duration radio button is clicked, the number in the text box will represent the total runtime in seconds. If the record count option is selected, the number in the text box represents the total number of records to gather. Moving right from this, we have power rails. This section is automatically updated based on the IRiser being used. As this IRiser is an IRiser5 Plus with an adapter, we can measure power on both 3.3 volt and 1.8 volt rails. Checking the boxes next to the power rail names will enable or disable their use respectively. Lastly, on the far right is the recording directory text box. This is the name to assign to the recording we're about to make. If this is left blank, the recording will automatically be assigned a name that is associated with the current time the recording was started. Under this, we have start time, end time, and a table. We'll come back to this. The last item here is the record button. Assuming we have all the other options set, we can hit this button to start recording. This is now a live view of the ongoing recording. It is updating at a max speed of once per second and is showing us the last X amount of data from all of the power rails that are currently being recorded. At the top left-hand side of the page, we have 3 buttons for power, voltage, and current. Pressing either of these will render the associated chart for this type of measurement. Underneath these is a recording summary table containing information about the full record. Further down, we have a recorded statistics view. This is updated based on what data is currently loaded on the main chart. As the chart is still live, these statistics are constantly updated to represent what's on screen. Let's quickly fast forward to the end of this recording and go through everything else on the page. Now the recording is finished, we'll look through some of the data. First, the chart. This is split into 2 segments, a main chart and the navigator. This is how we navigate around the recording. The data displayed here is a down-sampled version of the entire recording, allowing us to see the entire recording at a glance. To look through this recording in depth, we can move the sliders around on this navigator. The section between these 2 sliders is what gets displayed above in the main chart. This section of data in the main chart is the full non-down-sampled look at the area between the 2 sliders. Here we can mouse over or zoom in to view the samples in finer and finer detail. Above this is the current selection window. Here we can see information about what is being displayed on the main chart, including the start time, the end time of this segment, the number of samples in this segment, and at the bottom, a command that can be used to export this full segment to CSV data in the command line. Let's take another look at the main tab again. You can now see the start and end time of our last recording has been populated here. During the recording, this table was also being updated to count down to the end of the recording, a useful indication of when the recording would have completed. In the past recordings table, it's a new entry detailing our recording. This can be used to view the trace again if we ever navigate away from this page. Here, we can also delete the recording. Clicking this delete button will delete the recording. To finish up this IRiser demonstration, let's combine everything we've just learned. To start off, let's start a new recording. We'll call this one IRiser demonstration. We'll turn off the 1.8 volt rail and we'll record only on the 3.3 volt. Let's make it last for 5 minutes, and let's also turn up the frequency to 2000 samples per second. Then we'll hit record. Next, we'll head over to the GPIO tab to mess with some signals. As this runs on the 3.3 volt rail, we'll turn off the 3.3 volt signal, wait a few seconds, and then turn it back on again. Next, we'll head to the Actions tab. If you remember, Action 6 turned off the pulse signal for a time of 100 microseconds, and Action 7 turned it back on again. Let's edit Action 6 to last 250 microseconds and hit apply. Next, let's head to the Signals tab and we'll run this sequence. We'll wait for it to finish, and now we can head back over to the Power tab. Great! It looks like we can see 2 distinct events have just occurred. Let's stop this. We can now view this recording in finer detail. The first event shows us the effect of powering off the drive's 3v3 rail and powering it back on. We can see how the drive spikes in power when it turns back on, and all of the associated statistics to do with this. We can also see how the sequence that ran our 250 microsecond pulse glitch has affected the power. This concludes the IRiser software demonstration. As a last note to all users, everything you have just seen can be achieved in the command line interface. In the background, you can see a few of these IRiser commands that are used to achieve some of the different actions. These commands are fully scriptable and can return data in a JSON output. For more information about this, or the web interface, please see the IRiser Quick Start Guide and user guides on our website.
Thank you, Matt, for the deep dive into the software. We hope you have much success testing your drives with the IRiser5 In addition to the IRiser5 we also have an IRiser6 and an IRiser6 SE. The IRiser6 will ship as a standard iRiser for the upcoming SB Express, ARM6, and DT6 platforms. Check back here for more videos, including a deeper dive of the IRiser6 coming soon. Until next time.